Hi, in this video I am going to solve a problem on replacement model under the condition of replacement of items whose maintenance cost increases with time and the value of money getting changes. So before going to solve the problem, we must know some basic terms which we are going to use while solving the problems. First one is present value. So I am going to explain these terms with some examples. Let us assume that I am going to borrow some amount of money. It may, for example, 1,000 rupees from my friend with the interest rate of 10 percentage per year. So after 1 year, I have to repay the amount of rupees 1,100. So which means I have borrowed 1,000 rupees and I have repaid 1,100 rupees. Okay, so that extra 100 rupees is the rate of interest. So which means that today's 1,000 rupees is equal to 1,100 rupees after 1 year. In some other ways, so I can say that 1,100 rupees after 1 year is equal to 1,000 rupees today. So here I'm going to tell two contradiction statements. First one is from my friends. Let us assume my friend side. So he has lended 1,000 rupees, and he had got 1,100 rupees, which means he had got extra 100 rupees. So the money is getting changes with respect to time. This means the money has been increased. From my side, I have borrowed 1,000 rupees, but I have repaid 1,100 rupees, which means 1,000 rupees extra I have paid, which is loss for me. So that is the rate of depreciation, we can say. So next term is present worth factor. So with the above example, the 1,000 rupees is the principal amount P, and the excess amount I paid is 100 rupees, that is rate of interest, and n is the number of years I have taken to pay back the amount. So in the above said example, I have taken 1 year to pay back the amount. So with this cost, so we can write the equation like a equal to p into 1 plus I power n. So a is the payback amount, the final amount. So P is the principal amount, I is the rate of interest, N is the time taken in years. So rearrange this equation, P equal to A divided by 1 plus I the power N. So in the second equation, keep the A as it is, and the rest of the term 1 by 1 plus I power N is the present worth factor. So based on this present worth factor, the final amount to be paid is going to be changed. And the third term is depreciation ratio or discount factor. So as we know that the maintenance cost of any system or machine getting increasing with respect to time. So the value of money is going to be decreased with a constant rate, which is known as depreciation ratio or discount factor, and it is denoted as D. So with some simple equation, it can be represented like D equal to 1 divided by 1 plus I. So I is the rate of interest. Okay, now let's start to solve the problem. Assume that present value of 1 rupee to be spent in a year's time is rupees 0.9, rupees 0.90, sorry, and the purchase price P equal to rupees 3,000. The running cost of the equipment is given below in the table. So the running cost is given in this table for 7 years. The question is, when should the machine be replaced? So first read out the first line. Assume that present value of 1 rupee to be spent in a year's time is rupees 0.90. This means today's 1 rupee is equal to zero point 0.9 rupees in the next year. So this is the discount factor, and the purchase price, the capital amount which is or the purchasing the equipment is rupees 3000, and the running cost is the maintenance cost in each year. So we can able to see that the running cost is getting increased with respect to time, and also the invested amount is getting decreased by the discount factor zero point 0.9 by every year. So we have to find out the time at which the machine has to be replaced. So make the table as, as we discussed in the previous videos, in the previous cases. So the first column is year, the first year, and the maintenance cost in that particular year is 500 rupees, and the discount factor. So as we know that for the first year the discount factor is 1.0 in all the problems. So for first year the discount factor is not 0.90. For the first year it is 1. The next year onwards it will be in terms of 0.9, and the discounted maintenance cost equal to maintenance cost into discount factor. So u of t into d. So u of t is the maintenance cost and d is the discount factor. So multiply both the terms, becomes 500, and the total cost equal to principal amount, that is p into u of t, sorry, p plus u of t into d. So which means, so this 3000 plus this 500 becomes 3500, and the cumulative discount factor, so this is the first year, the cumulative discount factor is same as it is, and the average cost equal to total cost divided by the cumulative discount factor. So this becomes 3500. For second year the maintenance cost is 600 rupees, and the discount factor, so discount factor in the previous year, sorry, into the given discount factor 0.9 is equal to 0.9. So this is the discount factor for second year, and discounted maintenance cost equal to maintenance cost into discount factor in the particular year. So 600 into 0.9, this becomes 540, and the total cost equal to, so add 3500 plus this 540 becomes 4040, and the cumulative discount factor equal to the cumulative discount factor in the previous year plus discount factor in the present year. So 1.00 plus 0.9 becomes 1.9, and the average cost equal to 4040 divided by 1.9 becomes 2126. For third year the maintenance cost is 800 rupees, and the discount factor equal to zero point 0.9. So this is the previous year discount factor into common discount factor 0.9 is equal to 0.81. So multiply 800 into 0.81 becomes 648, and the total cost equal to, add 4040 plus 648, 4688, and the cumulative discount factor equal to 1.9 plus this 0.81 2.71, and average cost equal to 4688 plus 2.71 becomes 1730. For fourth year, the maintenance cost is 1000 rupees and discount factor the 0.81 into 0.9, so it becomes 0.73, and the discounted maintenance cost multiply 1000 into 0.73 becomes 730, and the total cost equal to 4688 plus 730 becomes 5418, and the cumulative discount factor 2.71 plus 0.73, so becomes 3.44, and the average cost equal to 5418 divided by 3.44, 1575. So for fifth year the maintenance cost is 1300, and the discount factor equal to 0.73 into 0.9 becomes 0.66, and multiply 1300 into 0.66 becomes 858, and the total cost is equal to 5418 plus 858 becomes 6276, sorry 76, and the cumulative discount factor 3.44 plus 0.66 becomes 4.10, and the average cost equal to 6276 divided by 4.10 will be 1530. For sixth year the maintenance cost is 1600, and the discount factor equal to 0.66 into 0.9 becomes 0.59, and multiply 1600 into 0.59 becomes 944, and the total cost equal to 6276 plus 944 equal to 7220, and the cumulative discount factor 4.10 plus 0.59 becomes 4.69, and the average cost equal to 7220 divided by 4.69 becomes 1539. For seventh year the maintenance cost is 200 rupees, and the discount factor 0.59 into 0.9 becomes 0.53. Multiply these two terms, 2000 into 0.53 becomes 1060, and the total cost equal to 7220 plus 1060 becomes 8280, and the cumulative discount factor equal to 4.69 plus 0.53, 5.22. 5.22. The average cost equal to 8280 divided by 5.22, that is 1586. 1586. So now almost we have solved the problem. We have to come to a small conclusion when the machine has to be replaced. So take these two columns, maintenance cost and average cost. Look at these two columns. So in the first year the maintenance cost is 500 and the average cost is 3500. So the average cost is more than the maintenance cost. So we have to see the pattern for the entire duration. For the second year also the maintenance cost is less than the average cost, and third year the same nature, the fourth year also the same nature. The fifth year the maintenance cost is 1300 rupees, and the average cost will be 1530. In the sixth year the maintenance cost will be 1600. So look at these two terms. The maintenance cost in sixth year is more than that of the average cost in the fifth year. So this is the transition period, we can say simply. So the machine has to be replaced at the end of fifth year. So if we go with the same machine for the next year, the maintenance cost will be increasing, so it would not be economical to the company. So the responsible person has to replace the machine at the end of 5th year. The machine has to be replaced at the end of 5th year.